Hello everyone. Um, Today we shall be continuing with our discussion of on statistics about descriptive statistics. Um, you'll recollect that last week we discussed about charts and graphs, and we examined the various types that we have available, and the formatting and the labeling to make it appropriate. But today we will be looking at descriptive statistics, which has made two major components of measures of central tendency and measures of spread. In there we shall be looking at calculation of mean, median and mode, and also quartiles, range and standard deviation. This topic is very important because in the study of research is done by most individuals, you realize that this is usually the beginning and it becomes a lifetime tool. Hence, I assure you that today promises to be a pleasant one. As I will be piloting you, I assure you a very comfortable, joyful, and safety ride. Thank you very much. Good day, everyone. We will be continuing with our study of statistics. You will recall that we treated the types of charts last week, where we examined histogram, bar charts, pie charts, and other form of charts and graphs, and the various uses we could employ them into. Today we'll be looking at descriptive statistics, which is a useful tool for analytical purposes, and it includes the various methods and approaches that we use for preliminary empirical investigation and analytical purposes. The method cuts across so many stratas of research and has a very wide uh, variety of uses, and I'm very sure that by the time we finish this lesson you will appreciate the importance of the topic we're discussing today and the various uses in which it could be readily employed. Like I said, um, our learning objectives is to define and explain what is descriptive statistics, measures of central tendency. Why is it important? Why do we actually want to calculate measures of central tendency or even study descriptive statistics? And be able to calculate mean, median, mode, standard deviation, range, and interquartile range, and use the calculation to for analytical purposes. And for this study we'll be making a very practical and relevant example to the students, so that you will see how practical this topic could be applied even in everyday life. And I said, it becomes a lifetime tool that you will use on a regular basis once you are still on this planet Earth. So descriptive statistics majorly can be divided into two. We have what we call measures of central tendency and what we call measures of spread. Under measures of central tendency, we have mean, median, and mode. And under measures of spread, we have range, quartiles, and standard deviation. Mean is a method that we use to find the average of a particular data. And what it is that you will add up all the figures in a particular data set and you find the average of the figures that you've added together by dividing with the number of objects or number of data items that make up the particular data that you added up initially. And like I said, we are going to have a practical example. And a good example we'll be using is to find out the an attempt to calculate the mean of a particular data set. And in trying to calculate the mean of a particular data set, we will use the figures that are available for your scores in a particular term. And we will find the mean of your scores over time. And in trying to find out the mean of your scores, we'll make examples. Let us assume that you're writing 11 modules in a term, and your score in each module will be as stated here, maybe 65, 74, 61, 70, 55, 56, 53, 63, 76, 57, and 63. Therefore, we call the scores for average, the scores for all the modular, for all the modules in a particular term, your x's. And therefore, to find out your mean, you find that you take the summation of all the x's and you divide it by the number of modules you have taken in that particular term. If you find out the modules that we have discussed here, there will be 11. So the summation of x divided by n, and our n will be 11, and that's what we've done here. The summation of x added together gives us 693, divided by our n, which gives us 11, means the mean of your scores for the modules you've written in that particular term we are considering is 63. And that translates to your average score for the term is 63. So it's easy for you to actually look at it and say, in this particular term, you are on a grade point of 4. And this is the number that is, and we can now go into median. Median is a number that is placed in the middle of a data that you are considering. In other words, it is the middle figure of an ordered or arranged data. And the formula we normally use in calculating median is n plus 1 divided by 2. Then you find the item in the series you are considering. And n in this particular case is the number of items or number of values you have in that particular data set being considered. We are still going back to our previous terminal module score data, which you used previously in calculating mean. And when we apply that, there's a procedure in calculating median. The first thing is that you must rearrange the data in an ascending order. So in that, if we're going to do that, rearranging our data, we'll now have it from 53, 55, 56, 57, 61, 63, 63, 65, 70, 74, and 76. So if we apply the data of the median we've given before, our n will be 11. And if we apply it, n plus 1 divided by 2 will now be 12 divided by 2, which means the sixth item in the data becomes our median. If we go back to the data, the sixth item from in the ordered or rearranged data becomes 63. Therefore, 63 is the median figure for this particular data. You'll find it that it's very easy to calculate median. In fact, to calculate all measures of central tendency is not difficult at all, and it's very, very practicable and relevant for daily uses. And we go also to find out how we calculate mode. Mode is the most common figure in the data. In other words, it is the figure that appears more frequently than others. If we go to the data set we have been using, we arrange the data and use the data that we arrange in an ascending order, which we used in calculating median. And if we look at it, you will see that of all the figures in the data, it is only 63 that appears twice. All other items or figures in that data appear just once. Therefore, it is easy for us to say 63 is our modal figure, or 63 is our mode. Continuing further, we can go into how to calculate measures of spread. And the first one we want to look at is range. Range is a measure that deals with the spread of a data. More or less, it is the difference between the maximum value and the minimum value in the data. In order to calculate range, essentially, like we did for median and mode, we must rearrange the data in an ascending order. And we use the data in an ascending order. We will see the highest figure or the maximum figure is 76, while the lowest figure is 53. Therefore, our range is 76 minus 53, and that gives us 23. So the range in this particular data is 23. And it must be noted that this range has no relationship to the central value which we have hitherto calculated. Neither does it provide any detail about the data that we are considering. It is just to tell us how far apart or how diverse the data we are considering is. And after completing calculation of range, we move into calculation of quarters. Quarters are points in a data that divide the data into 4 equal parts. More or less, the 25th percent point, the 50% point, the 75% point, and the 100% point. This approach provides more information about the data than the mode which we calculated earlier. As the name applies, quartile is of the range of quantile and denotes 4 points that marks the data, the quarter, the middle, the three-quarter, and the uppermost value in the data. Therefore, the 4 points to be considered as follows. The first quartile is 1/4 way through the data. The third quartile is 3/4 way through the data. Of course, the second quartile is the median, and the fourth quartile is the upper value of the range, which is what we used previously in arriving at our range. So for us to calculate the quarter 1 is called Q1, and it is the 1/4 way into the data, and it is nothing but n+1 divided by 4. Recollect that when we wanted to calculate the median, we used n+1 divided by 2 item. So in this case, it's going to be n+1 divided by 4, because we are now talking of dividing the data into 4 rather than dividing the data into 2 for median. And the third quartile is now going to be n+1 multiplied by 3 divided by 4. It is the ordered observation. Now, rules for appropriation. There are rules that we use to appropriate, because there are occasions when it becomes difficult to agree on the particular integer that makes up the quarter. So we have some underlying rules that we use. And the rule 1 says, if the resulting positioning points is an integer, that particular numerical observation corresponding to that positioning point is chosen for the quarter. Rule 2, if the resulting positioning point is halfway between two integers, the average of their corresponding observation will now be chosen. And the third rule is, if the resulting positioning point is neither an integer nor a value halfway between two integers, a simple rule is to round off to the nearest integer and select the numerical value corresponding to that observation. And rule 4 is, calculation of Q2 is the same thing as median, which we treated earlier under measures of central tendency. Now we want to calculate quartile 1. we have the same data which we used in calculating median and mode. And we now find out our Q1, which is n plus 1 divided by 4. Our n in this particular case is 11 plus 1 gives us 12, and divide by 4 gives us 3, which means the third observation in this particular data is our Q1. And in that data, 53 is the first observation, 55 is the second observation, 56 is the third observation. Therefore, the third ordered observation, which is 56, is our Q1. Now suppose we extend our data to 12 rather than 11 observations by adding another upper limit figure of 80 to the data. So the data now extend from 76 as the maximum or highest figure to 80. If we want to calculate Q1, we have n plus 1 divided by 4, which is what we used before. But note in this case that our n has moved from 11 to 12. So n plus 1 becomes 12 plus 1 divided by 4, which is 3.25 ordered observation. In this particular case, we will have to apply the third rule. And remember, our third rule, what does it tell us? If the resulting positioning point is neither an integer nor halfway value between two integers, the simple rule is to round off to the nearest integer. And in this particular case, you will see that our Q1 is 3.25. It is lower than 3.5. So 3.25 is closer to 3 rather than 4. So, and it's even not 3.5. So we cannot apply rule 1 and rule 2. So we will apply rule 3. And which means our Q1 still becomes the third observation, which makes it to remain at 56. Please note that we have earlier calculated median, which is the same as Q2 using our previous data. However, in a bid to explain rule 2, we will use the extended data to calculate Q2. Now remember that we are using the extended data where n is now 12. N plus 1 is 13. Multiplied by 2 gives us 26. Divided by 4, we will now have 6.5 ordered observation. In this particular case, the rule 2 will be applied. And recollect that rule 2 tells us that if the resulting positioning point is halfway between two integers, that is, it is 0.5 between two integers, 3.5 is halfway between 3 and 4. And in this case, we have 6.5, which is halfway between 6 and 7. The average of their corresponding observation will now be chosen. Therefore, to apply this, we will take the 6th and 7th observation and add them together and divide by 2. And the 6th and 7th observation in this case happens to be 63. Added together gives us 126. And we divide by 2, we still have it as 63, which means that the data having median as 63 is a good representation. Now we move to calculate Q3 using our extended data. We now have it, and our Q3 becomes 12 plus 1 multiplied by 3 divided by 4. That gives us 9.75 ordered observation. In this particular case, we are going to apply rule 3, which we used when we calculated Q1 with the extended data. You will see that 9.75 is far from 9, but it's closer to the 10th observation. Therefore, we are going to pick the 10th observation as our Q3. And the 10th observation there is 74. Therefore, our third quartile is 74. I hope this is very clear about the way we are calculating the measures of spread. Thereafter, we move into calculation of standard deviation. Standard deviation represents the average difference between each individual value in the data and the mean value of the data sets. In essence, we want to know how far away is the respective values or figures in the data from the arithmetic mean that we have calculated. Therefore, to calculate standard deviation, we will first calculate the arithmetic mean of the data and subsequently deduct the arithmetic mean from the values of the respective datas or respective figures in the data. Let us go back to our data on terminal module score, not the extended version place. We are going to use that data where our n is 11, and we have a table where the data values are put there, and we have the main, which is 63, which we put in front of all the data values. We now take our data values, remember I call them x, our x's, and our mean is now called m. So we take deviation from the x's, and 53 minus 63 minus 10, 55 minus 63 minus 8, 56 minus 63 minus 7, 57 minus 63 minus 6, 61 minus 63 minus 2, 63 minus 63 0, 63 minus 63 0, 65 minus 63 2, 70 minus 63 7, 74 minus 63 11, 76 minus 63 13. And it is easy for us to just take a summation of our x minus m. If you do that, you will realize that it will give you a 0. Therefore, we take a square of the x deviation from mean. Therefore, minus 10 squared is 100, minus 8 squared is 64, minus 7 squared is 49, minus 6 squared is 36, minus 2 squared is 4, minus 0 squared is 0, minus 2 squared is 4, 7 squared is 49, 11 squared is 121, and 13 squared is 169. Taking a square of our deviation from mean has helped us to eliminate the minus figure that would have allowed our data to result in 0. Now we take the summation of our deviation from mean, and that gives us 169. So this we have presented in column 4 above, and the summation gives us 169. Now we apply this to the formula for standard deviation, which is the square root of variance, and that is the square root of variance, where our variance is summation of x minus m squared divided by n, where n is the number of objects or values in a sample of 11. Variance is now going to be 196 divided by 11, 596 divided by 11, which gives us 54.18. We now take the square root of 54.1818, and that gives us 77.3608. So our standard deviation becomes 7.3608. So in conclusion, we have successfully studied measures of central tendency and spread, and we have used a very applicable example that you will continuously practice with and assist you to actually understand and come to terms with what we mean by measures of central tendency and measures of spread. I sincerely hope you are better equipped with the knowledge of descriptive statistics and happy to play with it anyway. Please check the quiz corner to test your proper understanding of the lesson. Thank you very much.